I'm Gayle Baker, professional engineer, and on behalf of my coworker, Casey Glace, engineer in training, we are excited to show you a little bit about our career in agricultural engineering. When we were selecting our major in college and also our career path, we made decisions based on our interests and passions. We both grew up on a livestock farm. Casey grew up on a beef farm in Minnesota, and I grew up on a dairy farm in Iowa. We both enjoyed solving problems, math, and science. Being involved in extracurriculars like 4-H and FFA helped us learn more about the agricultural industry. We both knew we wanted to be involved in the livestock industry. During college, we continued to evaluate if we were on the right path by participating in internships, research, and networking with other ag engineers. Agricultural and biological engineering is a broad career path, so during our college studies, we had to narrow down our focus area. Agricultural and biological engineering is commonly divided into 5 areas: power and machinery, food processing, and biorenewable resources. Casey and I focused on the structures and environment and water quality and natural resources area. We love our job because we get to work directly with producers to accomplish their goals, perform work outside like soils investigation, surveys, and construction observation, and we get to help navigate federal and state permitting. The big question we get asked is, why do you care so much about manure? Well, let's start with how much manure livestock produces. A 1,400-pound milking dairy cow can produce around 18 gallons of manure per day. That is 6,500 gallons per year per cow. How much manure would a farmer need to manage if he has an average herd size of 200 cows? A beef finisher animal of 1,400 pounds produces 8 gallons of manure per day. That is 300 gallons per year per animal. How much manure would a producer need to manage if he had a feedlot with 500 head of finisher cattle? A mother sow or pig who averages 500 pounds produces 3.5 gallons of manure per day. If you have a farrowing barn for 1,000 head, how much manure would a sow farm operator need to handle? Because these numbers are so large, livestock producers need to have the facilities and containments to handle the manure volume until they can properly utilize the manure. Curious of how a flush system for a dairy farm is designed and operated? Let's take a quick dairy tour. First, the manure is flushed from the freestall barn. The freestall barn is where the cattle eat and sleep. They sleep on sand beds. A few times a day, their manure is flushed out of the walking alleys. Next, the sand is settled out in the sand lane and reused for bedding. The flush water is caught in a flume pipe and is outlet to the sand lane. The sand lane is designed so the velocity of the water slows down just enough to settle the sand out, but the water and the manure solids continue on. Sand is reclaimed for bedding for the freestall barn. This is one way to have renewable bedding. After the sand lane, manure solids are settled out in the settling tanks, and liquid manure is pumped from the settling tanks to the holding ponds. Manure solids are held back by a wheat weir wall and removed when they are dry. Flush water that is used for flushing the barn is pumped from the holding pond number 2 to the flush tank. This holding pond is a clay-lined storage. The clay does not allow seepage of the manure from the structure. Finally, manure is recycled as fertilizer for crop production. Manure is removed from the storage structure and applied to crop fields. Manure provides 3 major nutrients: nitrogen, phosphorus, and potassium. The crops produced are used to create on-farm feed, and the whole cycle starts over again. Everything produced on the farm is reused as much as possible. Thank you for watching our career exploration video for WCFA. Reach out to us if you have any questions or are interested in learning more about agricultural and biological engineering.